OSPF neighborship. In this video, I am going to talk about the neighborship process in the OSPF. First, we should understand what is the OSPF neighborship. After that, what are the requirements of the OSPF neighborship, and also some other information related to the OSPF neighborship. You know that in the OSPF or also EIGRP, the first step in the routing process is the neighborship. Actually, first router 1 and router 2 should establish neighborship with each other. After that, they can exchange link state in the OSPF or EIGRP update in the EIGRP. Because of that, this is so important for troubleshooting process. When you want to troubleshoot one routing process, one routing domain, okay, the first step is checking the neighborship between the routers. Also, about the optimization of the function of one routing protocol, one of the for example, parts of our job related to the OSPF neighborship. Let me start to talk about the OSPF neighborship. First, I'm going to talk about that when we are configuring the OSPF on one router, what is happening. For example, you know that in previous video, we have learned about the configuration of the OSPF. Assume that in the router 1, okay, we are configuring this command, router OSPF1. You know that 1 is the process ID, and after that we can use the network statement, network 10.1.2.1 quad 0, then area for example quad 0. What is happening? I'm going to talk about that, what is happening with this configuration. First, let me say that when you are configuring the router OSPF, okay, the first thing that is happening in the OSPF is that the OSPF is choosing one router ID, and you know that how router ID is selecting in the OSPF. For example, assume that here we didn't configure the router ID. When you are configuring router OSPF 1, router 1 automatically can choose its a highest IP address about the loopback interface, or if the loopback interface is not available, other interfaces, non-loopback interface should be selected as the router ID. For example, in the router 1, now the router ID is the 10.1.2.1, the IP address of this interface, because we have only one interface. After that, because we have configured the network statement on the 10.1.2.1 quad 0 means please enable OSPF on this interface. Okay, what does it mean? It means that here after this command we will have this multicast IP address, such as the EIGRP. Here we will have one multicast, but the multicast address is 224.0.0.5. This is the reserve multicast address from the INA, Internet Assigned Numbers Authority, okay, for the OSPF. We are using this multicast address in the OSPF for example, dynamic neighborship or dynamic neighbor discovery. Multicast address reserved for OSPF is 224.0.0.5. Also, you know that when we have one multicast address on one interface, automatically we will have one multicast MAC address. Okay, this MAC address associated with this multicast IP address. Okay, multicast MAC address of the 224.0.0.5 is 0100 dot. After that 5E, let me to write here 00.0.0.5. This means that after configuring the OSPF, you will have this multicast IP address, the 224.0.0.5 on this interface, on the serial 10, and also we will have multicast MAC address if that interface is the Ethernet interface, because here we have serial interface, we don't have this multicast MAC address, but if the interface is Ethernet interface, we will have this multicast MAC address. After that, on this interface, the OSPF is sending hello packets. In OSPF, we have multiple type of packets. The first type of packet is the OSPF hello. The second type of packet is the link state request. I will talk about them. Then we will have link state for example update. Then we have another packet, we call it DBD, and also the link state acknowledgement. You will learn about them: hello, link state request, link state update, database description, and link state acknowledgement. All of them will explain in the future in this class, but for now let me to say that in OSPF like EIGRP we are using hello packets for establishing the neighborship between router 1 and router 2, actually for discovering the neighbors, and after that for maintaining the neighborship. Here now we are talking about the OSPF hello packet. Actually, after our configuration on this interface, we will experience the OSPF hello. You know that the source IP of the OSPF hello is the unicast IP address 10.1.2.1. This is the hello, okay, of the OSPF, and destination is the 224.0.0.5. Why we should send the hello to the 224.0.0.5? Because we know that if in the other side we will have one OSPF neighbor, one OSPF configured interface, on that interface we will have 224.0.0.5 IP address, and with this mechanism we will find the router 2 automatically. This is the process of the OSPF. Assume that in the router 1 we are configuring with the traditional method, but in the router 2 we are configuring with the, for example, named method. The method of configuration is not important. Assume that here we are going to the interface serial 10 and using IP OSPF 1 area quad 0. Okay, what is happening? Again, the same process. The first thing that is happening is choosing the router ID. You know that when you are configuring the router in the router 2, this commands interface serial 10 IP OSPF 1 area quad 0, automatically on the running config we will have router OSPF 1 without any configuration. Actually, you are enabling the router OSPF 1 process, but the configuration of OSPF is finishing on the interface. Because of that, again, the router 2 should choose its router ID 10.1.2.2, for example. Then, because we didn't configure the loopback 0, after that multicast IP address, multicast reserve IP address for the OSPF should be enabled automatically on the serial 10 interface. Okay, and if this interface will for example Ethernet interface, we will have also this MAC address, and again on this interface we will see the OSPF hello packets. These OSPF hello packets is sending to the 224, okay, and with the source of 10.1.2.2. Let me to say that in these hello packets we have multiple information. I will talk about them, but finally after this hello sending and receiving, we will have OSPF neighborship between the router 1 and router 2. First, let me to show you until here what is happening. We should configure this scenario. This is the router 1. As you can see, we don't have IP address on the router 1. Let me to assign IP address to the interface serial 10. Okay, after that we can enable OSPF IP address 10.1.2.1.255.255.0 and then no shutdown. Now let me to assign IP address to the router 2 also. This is the router 2 conf t interface serial 10 IP address is the 10.1.2.2.255.255.255.0. No shutdown. Now let me to configure OSPF first on the router 1 with the traditional method. Router OSPF 1, you know that after this command the OSPF should choose its router ID. Okay, as you know, I didn't configure any things in the do show IP protocol. Okay, we can see that the router ID is available 10.1.2.1. This means that after enabling the OSPF, okay, after router OSPF 1, we will have the router ID. This is the first thing that is happening. After that, let me to enable the OSPF with the network command, network 10.1.2.1 quad 0. Okay, then area again quad 0. That's it. Now we have OSPF on the interface serial 10. After this command, you can see that here on this interface we have the 224.0.0.5 IP address with the do show IP interface serial 10. Look at here. On this interface, beside of 10.121/24 as the unicast IP address, now we have 224.0.0.5. This is the multicast reserve group for the OSPF, and because we have enabled OSPF on this interface, now we have this multicast address on this interface on the serial 10, and also now we are sending hello on this for example OSPF. If you want, you can use debug OSPF packets, debug IP OSPF, for example hello. Okay, here on the serial 10 we will have some hello packets of the OSPF. Also you can capture the link between the router 1 and router 2. Let me to show you what is happening here. Start Wireshark. Also in the debug, you can see that for OSPF process 1, we are sending hello over the serial 10. Destination is 224.0.0.5 and source is 10.121. Okay, look at here. This is the OSPF packets. Now we have 10.121, 224.0.0.1, 0.0.5, and then OSPF. In OSPF, by default, we are sending each hello in 10-second interval. We call it hello time. You will learn about it. After that, now we should enable the OSPF on the next interface on the router 2. Okay, as you know, in the router 2, I didn't configure OSPF at all. Here, I'm going to configure IP OSPF1 area, for example, quad 0. Okay, you will see that here we will have one neighborship. This is our neighborship. But before talking about the neighborship, let me to say that in the do show run, in the running config, now beside of the configuration of the serial 10 here, that we have, for example, OSPF configuration. Here you can see that we have router OSPF1. Actually, we are configuring only the OSPF, for example, configuration on the serial 10 about the enabling OSPF. Other configuration should be done on the router OSPF1. Okay, what is happened in the router 2? Again, in the do show IP protocol, you can see that we have router ID. Why router ID is quad 2? The reason is that in the router 2, I have configured one loopback interface, show IP interface brief, because loopback interface has higher precedence about the router ID. The router ID is quad 2. Maybe you ask me, we didn't configure OSPF on the quad 2. Yes, I know this is not important. When you have one loopback interface without regarding to that, for example, that on this interface we have enabled OSPF, or we didn't have any, OSPF. The OSPF can choose the IP address of the loopback for the router ID. Look at here in the R1. Now we are receiving and sending hello. Send hello, receive hello. Okay, send hello, again receive hello. In the capture also you can see that we have hellos from the router 1, from the router 2, router 1, router 2, router 1, router 2. It is so easy. Let me to undebug the debug. And here in the show IP OSPF neighbor, you can see we have one neighbor. The neighbor is quad 2. Okay, and the IP address of the neighbor is 10.122, and then over the interface serial 10 we have one neighbor. After that, in the router 2, show IP OSPF neighbor can show us our neighbor ID. Okay, is our neighbor ID means the neighbor router ID is 10.121, because here we didn't have loopback interface, and also the IP address of the router 1 is 10.121, and we have neighborship over our interface serial 10. Until now, we have learned what is happening when we are enabling the OSPF. What the next things that we should talk about, that is the neighborship requirement, neighborship conditions. What should be happen to for neighborship? You know that in each routing protocol we have a different routing, different neighborship conditions. Okay, and in OSPF also we have different neighborship condition than the, for example, EIGRP. We should talk about them, and also we should learn about them. And let me to talk about the OSPF requirement for neighbor adjacency. Look at here. The first requirement is that the RID, means router ID, must be unique between the two devices. This is obvious. Look at here. The first requirement is that the router ID between two routers should not be equal. You know that now in the router 1, the router ID is the for example 10.121, okay, and in the router 2 the router ID is quad 2. In most cases we don't have any worry about the equal configuration of the router ID, because the router ID can be selected automatically from the IP addresses of the interfaces, okay? And because the IP address always is unique, we can ensure that the router ID also is unique. But in some cases, we are configuring ourselves the router ID, and this is possible that we configure two router ID with same ID. For example, router 1 with quad 2, router 2 with quad 2. And after that, we will have the two router ID with the same value. Maybe you ask me why router IDs should be unique. You know that in OSPF, we are creating a topology, a map of network. After that, we are running a SPF on that topology. It is important to configuring unique router ID. Why? Because the router ID is the unique identifier of one router in the topology. Actually, if you have two router with same router ID, we don't have any differences between those routers in the topology. Because of that, it is important, it is necessary, it is mandatory to configuring the unique router ID for each router. Because of that, this is one of the requirements. If you configure two router with the same router ID, the neighborship will not establish. Let me to show you. In the OSPF hello, this is one of the OSPF hello. Let me to show you the content of this OSPF hello. As you can see, OSPF is sending its packets, okay, over the IP directly, and the protocol number of the OSPF is 89, okay. And also here we have one OSPF packet. This is the OSPF hello packet. In each OSPF packet, we have OSPF header and then the content of the OSPF. OSPF header contains some information. For example, you know that we are using OSPF version 2. The message type is type 1 or the hello packet. This is the packet length, 48 byte, okay. And source OSPF router means source OSPF router ID, okay, means the router ID of the router sending this hello is quad 2. This is the hello received from the router 2, but in the hello received from the router 1, as you can see, the router ID is the 10122. Actually, inside of each hello, we have the router ID. Let me to configure the router ID with same value in both routers. I'm going to show you what is happening. Look at here. You know that the result of this action will be, for example, tearing down the neighborship. In the R1, I'm going to configure the same router ID with the router 2. Router, okay, router OSPF 1, router ID quad 2, and then do clear IP OSPF process. It can show us that now the router ID is changing to the quad 2. As you can see, neighborship goes to down state, and here we are receiving one error message. Duplicate router ID. Here we have log message from the OSPF. This is facility, this is severity of 4, and this is the mnemonic duplicate router ID about the neighborship, and this is the message type, message of the log. OSPF detected duplicate router ID quad 2 from the 10122, means from the router 2 on interface serial 10, and because of that, we will not have neighborship. Do show IP OSPF neighbor can show us that we don't have neighborship between the router 1 and also the router 2. It is obvious. Also in the hello message, you can see that here we are receiving, for example, hello. As you can see, from the router 2, router ID is quad 2, from the router 1 again is quad 2. Because of that, we will not experience the the OSPF neighborship, and we should correct this problem. For in the R1, we can configure the router ID quad 1. Because we don't have a neighborship now, you don't need to clear IP OSPF process. And after this command, you will see that we will have new neighborship. That's it. Again, in the hello packets, we have this information. Look at here. Hellos of the router 2 contain the router ID of quad 2. Hellos from the router 1 contain the router ID of quad 1. Because of that, in the router 1, do show IP OSPF neighbor can show us that we have neighborship with the router 2, quad 2, and in the, for example, router 1 or router 2, we can see that we have neighborship with the router 1. Show IP OSPF neighbor. It is obvious that we have neighborship with the router 1. That's it. This is the first requirement for the neighborship. The RID must be unique between the two devices. Let me to talk about the second for example, condition. The second requirement is that the interface must share a common subnet, exactly the same requirement that we had in the EIGRP. You know that when we are working between two routers about the OSPF neighborship, we need to use these two interface to configure these two interface with the common subnet about the unicast IP address. Why? Assume that we are configuring two interface with two range of IP addressing. We cannot send traffic from the R1 to R2. Because of that, the OSPF neighborship is not useful. Assume that R2 is sending some routing information to R1, but we don't have a pass from the R1 to R2. Let me to show you. This is important to know. We have R1 connected to the R2 and also R2 connected to one network, net A. Here we are using 10.121/24, but here we are using 10, for example, 131/24 on the router 2. Okay, what is happening? If assume that we have OSPF neighborship, router 2 can send the net A, can inform the net A to the router 1, but router 1 cannot use this information because the router 1 cannot send traffic to the router 2. Here we are using two different range, and because of that, this is one of the requirements that we are using the common subnet between two routers. Let me to show you what is happening if we configure different range. For example, in the router 1, we have configured 10.121/24. In the router 2, I am going to configure interface serial 10, IP address 10.131, then 255.255.255.0. Because we have configured before OSPF on this interface with the interface specific command, we don't need to configure OSPF again. Here, you can see that the neighborship goes to down state. Okay, do show IP OSPF neighbor can show us that we don't have neighborship. Also in the router 1, we don't have a neighborship. Let me to show you the hello packets. The hello packets received from the router 1. Source is 10.131, destination is 224.0.0.5, and here the source is 10.121, destination is 224.0.0.5. But we don't have a neighborship in the router 1. Also do show IP OSPF neighbor. As you can see here, we don't have neighborship R1 and R2. Because of that, one of the requirements is that we should configure two interfaces IP address with common subnet. In the router 2, let me to correct the configuration of IP addressing. Interface serial 10, IP address is 10.122.255.255.255, then 0. We will have neighborship between the router 1 and router 2. As you can see, do show IP OSPF neighbor. We have neighborship, and also here do show IP OSPF neighbor. This is the next requirement related to the neighborship. Let me to talk about the next neighborship condition or neighborship requirement. The interface maximum transmission unit or MTU must match. Here, let me to give you a little more information. You know that for each interface, okay, in one router, we have a value, we call it MTU, okay. MTU is the abbreviation of the maximum transmission unit. Maximum transmission unit. What does it mean? The maximum transmission unit, the maximum packet size that we can send from this interface. If the packets, if we receive one packet with more than this MTU, we should fragment it. Okay, for example, in most cases, the MTU of one interface is 1500 byte. Means from this interface, for example, from the serial 10, each packet, not each frame, each packet should have maximum 1500 byte of length. If you have packets with more size, you need to fragment them. This is the normal behavior. Let me to show you in the for example, router 1, you can use show interface command to verifying this status. Show, let me to write here with the show interface, then the interface name, you can verify the MTU of interface. In the router 1, do show interface serial 10. It can show us that the MTU of this interface is 1500 byte, and also in the router 2, do show for example interface serial 10. okay, can show us that the MTU 1500 byte. As you can see here, the OSPF expect to see the same MTU between two routers. Maybe you wonder about it, why we should use the same MTU between two routers. Let me to explain it. Look at here. You know that in OSPF we are sending the link states from one router to the other router, okay, R1 to the R2. In most cases, the link state, okay, because of the more efficiency, is using the maximum MTU size for sending its packets. For example, if the MTU size here is 1500 byte, okay, we are sending the link state with maximum size. Assume that we want to send a 3000 byte of data. We are using two 1500 byte of the link state. You know that we can use, for example, 3000 byte packets, but we are using two 1000 byte packet. Automatically the OSPF is using the maximum size. Why? Because we want to send lower number of packets because of lower header and some other things. This is more efficient. Okay, assume that we are sending with our maximum MTU, but in the other size we have the MTU of 1400 byte. What does it mean? It means that our packets cannot be accepted by the router 2. Because of that, it is important to ensure that the other side, okay, has the for example, MTU at least to the MTU of us. But again, about the router 2, we have the same risk and same consideration. Again, we should ensure that two routers are using the same MTU. Because of that, in OSPF, we should ensure that the MTU of two interface are same. But let me to say that if we don't have same MTU on these two interface, okay, you will see one a state of OSPF, we call it Xstart state. You will learn about the Xstart in this video, but for now, let me to say that the neighborship can, for example, establish until two-way state, okay, but after that we cannot go to the full state. You know that in normal neighborship, such as the do show IP OSPF neighbor that we have, the state is full. You will learn about the states in this class, but let me to say that when you are reaching to the full state means we can exchange the link state. But if you receive only to Xstart state, okay, this means that you have one problem. One of the possible problem is the MTU mismatch. I will show you. Let me to configure the MTU with different value in the router 1. For example, in the router 1 on the serial 10, we can use MTU command, then 1400 byte. Now, in the show interface serial 10, you can see that the MTU of this interface is 1400 byte, and in the router 2 is 1500 byte. Let me to clear the OSPF neighborship, clear IP OSPF neighbor or process, okay. And then what is happening? Look at here, after clearing the neighborship, as you can see, we will not see the new neighborship. In the show IP OSPF neighbor, you can see that our state is Xstart. Here we don't have neighborship. This is not neighborship. We cannot use this neighborship. Here you can see that the state of neighborship is Xstart, and this means that we cannot send information to the other router. Because of that, it is important to ensure that in both sides we are using the same MTU. Let me to configure it with the correct number, in correct value. Interface serial 10, then MTU 1500 byte. This is important to know that if you don't configure the MTU with the same value between two sides, we will not have neighborship. Show IP OSPF neighbor. Okay, you will learn more than this about the states, don't worry. Because of that, with the show interface name, we can see the MTU, and also if it is necessary, you can use MTU command for configuring the MTU of interface. Router config if, okay, the command is MTU, then the value of MTU in byte. So easy. After that, let me to talk about the next condition. The next condition is that the area ID should be matched between these two routers. It is obvious. Let me to explain it. You know that we are using the area for example, reducing the memory usage, reducing the CPU usage, and some other benefits. Okay, I have explained them. But assume that we have router 1 connected to router 2, connected to the router 3. and we are configuring between the router 1 and router 2 the same area, area 0, and between the router 2 and router 3 the area 1. This is for example, good design. Why we are configuring two area? Because we don't want to send link states received from the router 1, okay, in router 2 to the other area, to the area 1, and we don't want to send information that we have received in the link state from the router 3 in the router 2 to router 1. Okay, this is the rules of the area. We don't send topological link state from one area to the other area. Why? Because we don't want to we don't want to increase memory usage, increase CPU usage, propagating information of one area to other area, and some other things. Assume that this is a correct design, but assume that in the incorrect design we are configuring this area numbers, area 1. Okay, in the router 1 we are configuring area 0, and in the router 2 we are configuring area 1. Okay, what does it mean? And here also we are configuring, for example, area 0, and then other side area 1. What does it mean? It means that if the OSPF is working, we are sending the information of area 0 to area 1. This is not the for example, this is not good. Actually, this is in opposite of the goal of the area. Because of that, we should ensure that the area ID that we are configuring between the router 1 and router 2 is same. Here in the OSPF hello packet, you can see that we have area ID. Area ID is quad 0, means backbone, in the hello of the, for example, router 2, and in the hello of router 1. This is so important that we are using the same area ID between two routers. Let me to configure the router 2, okay, router 2's interface with another area ID. For example, until now we have used the area ID of 0. Do show IP OSPF interface brief can show us that area is quad 0. Let me to configure on the interface serial 10 IP OSPF 1 area 0001. That's it. Okay, now we have area ID mismatch. As you can see, mismatch area ID log is receiving. Do show IP OSPF neighbor can show us that we don't have neighborship. Also in here, show IP OSPF neighbor after some second after the time that you will learn about it can show us that we will not have the neighborship after, for example, the time is finishing. Because of that, one of the requirement in OSPF for the neighborship is the same. For example, area ID. You can use show IP OSPF interface name or brief for finding the area ID configuration. Look at here, we don't have neighborship. Show IP OSPF interface brief. Area is quad 0 in the router 1, in the router 2. Let me to show you. This is the router 2. Okay. We can use show IP OSPF interface brief. As you can see, the area is 0001. That's it. Let me to correct it. Interface, okay, interface serial 10 IP OSPF 1, then area quad 0 or 0. We don't have difference between the quad 0 and also 0. Now we will have neighborship. Because of that, the next requirement related to the OSPF neighborship is using the same area ID between two same interface. Let me to talk about the next neighborship condition. The next neighborship condition or requirement is the need for a DR must match for the segment or that segment. Let me to give you a little introduction about the DR and BDR. Until now, we didn't talk about the DR and BDR. In the next section, we will talk about the DR and BDR. Let me only say that in some networks, okay, we are selecting one DR means designated router in one interface, in one segment. Look at here, DR is the abbreviation of the designated router. Okay, you have learned about the DR in the CCNA class, but let me to review it. In some OSPF network types, for example, on the Ethernet interfaces, one of the interfaces, okay, in these networks, one of the interfaces should be selected as the DR. Why we should select the DR, why we need the DR, I will talk about them. But for example, in Ethernet networks, we are using DR, we are selecting DR or designated router. In the serial interface, by default, we don't select the DR or BDR. Okay, here you can see a requirement that if in one side we need the selection of the DR, okay, in the other side of the neighborship also we should have this same requirement that the DR should be selected. Or if in one side we don't need to selecting the DR, and in the other side also we should have the same condition. Maybe this is a little for example complex for you because you didn't hear about the DR and BDR. Let me to talk about the DR and BDR in the next section. You will understand more than this about the DR and BDR, and also why we need to have a DR requirement in both sides or non-DR requirement in both sides. Here you can see the need for a DR must match for that segment. What does it mean? It means that if the R1 interface needs to selecting DR, the R2 interface also should select the DR, should have this need to selecting DR. Or if the R1 interface doesn't need to select the DR, R2 interface also should, for example, doesn't need selecting the DR. I will talk about that. Don't worry about the DR. This condition can be understood in the next section more than now. Let me to talk about the next condition, the next requirement. OSPF hello and dead timer must match for that segment. First, we should understand what is the hello timer, what is the dead timer. After that, we can talk about the OSPF requirement about the neighborship related to the hello and also dead timer. This is so like the hello time or hello interval in the EIGRP and also dead time in the EIGRP. Let me to talk about the hello interval and also the dead interval or hello time, dead time. Both of them are same. Look at here. Assume that here we have router 1 and router 2. You know that when we are configuring on the router 1 interface OSPF, we are sending hello, okay, to the router 2. And also we are receiving hello from the router 2. And after checking these neighborship conditions, okay, after that we will have the for example neighborship or adjacency between these two routers. Okay, this means that the first function of the hello is discovering the other side, and after that establishing the neighborship. Also in hello we have some information. This information useful for example verifying the status of two sides, and after that if everything is working correctly we will have the OSPF neighborship. But after the neighborship, again we should send hello from the router 1 to the router 2, okay, and from the router 2 to router 1. Why we need to send again hello after the neighborship? The reason is for ensuring that the other site is for example alive, and also we have the similar properties or for example the correct neighborship conditions between two other. Actually we are sending hellos for ensuring about the aliveness and also ensuring about the for example correct parameters related to the neighborship. For example, R2 is using the unequal router ID with the R1, or for example we don't have mismatch in the MTU, we don't have mismatch in the for example subnet address or some other things. Because of that we are sending hello after the neighborship. This is for maintaining the neighborship, okay? But you know that when we want to send hello, we need to have a time that we call it the hello interval. This time is a time that is an interval that we are using it for understanding in which interval the R1 should send hello to the R2 and also R2 to R1. By default, OSPF is using the hello time as the 10 second. You know that in EIGRP we are using the OSPF, the EIGRP hello time 5 seconds. And also in the OSPF we have another time, we call it the dead time. Dead time by default equal to 4 times of the hello time. 4 times of the hello time is equal to the 40 seconds. What does it mean? It means that R1 should send, for example, each hello in a 10-second interval, and also the R2 should hold 40-second down counter for the R1. This means that if the first hello doesn't receive, it is not important. If the second hello it doesn't receive, again it is not important. If the third hello doesn't receive, again it is not important. But if the fourth hello doesn't receive in R2, the R2 should tear down the neighborship. This is a down counter. Okay, I can show you. Look at here in the router 1 and router 2. Now we have neighborship. If you want, you can see the hello time and that time with the show IP OSPF interface, the name of interface. Okay, you know that with show IP OSPF interface brief, we can see a brief explanation about each interface. Here we don't have any information about the dead time and also the hello time, but if you want, you can use show IP OSPF interface with the name of interface serial 10. Here you can see that the hello time is 10 seconds and dead time is 40 seconds by default. Okay, and you know that in some cases maybe you want to verify the dead time. Show IP OSPF neighbor, look at here, show IP OSPF neighbor can show us that now we have the dead time of 37. Look at here, then 31, 30, again 39, okay, 37, 36, 35, 34, 33, 32, 31, again 30, and then 39. As you can see, this is a down counter. From 40 we are receiving to 39, 38, 37, 36, 37, 35, 34, 33, 32, 31. Then the next hello is receiving. Again, we should reset the time to the 40 second. Again, 39, 38 to 30. Again, we are receiving the hello time. The hello, we should reset the timer of that time to 40 seconds. In some cases, maybe you want to for example, change these values. Why? Because we want to detect the change with for example, with a faster manner, or in the for example lower amount of time. For example, you want send hello in 5 seconds, that time in 20 seconds is 20 seconds. This means that after 20 seconds we will understand that the neighbor is not available, for example. Okay, or if you want to send hello time and or increase hello time and dead time. Why? Because we want to reduce the usage of bandwidth and also CPU usage because of the sending of hello and dead time. It is possible you can change the hello interval or hello time and also dead time in the OSPF. Let me to show you. You know that for each interface we can configure different hello interval and also a dead time. Because of that, we should configure these features, hello interval and dead time interface on interface. Look at here, router config. Then we should go to the interface mode, interface name, then router config. If here we should use IP hello, IP first, OSPF. Okay, means we are changing the hello interval for the OSPF. IP OSPF hello interval, a value between 1 to 65,535. As you know, here we are configuring the value in second. Okay, this is the second, 1 second, 2 second. The default is 10 second. Also about the dead interval, router config if IP OSPF, okay, dead again interval. After that, you can configure again a value between 65,535. Don't forget that if you configure only the hello interval without configuring the dead interval, the dead interval by default it can should be used, okay, and is using the 4 times of the hello interval. For example, assume that here I am configuring IP OSPF hello interval 5. Okay, that interval will be 20 seconds. I will show you. Also, as I mentioned before, if you want to verify the value of the hello interval and dead interval, you can use show IP OSPF. For example, interface, then the name of interface. Here you can see the hello interval and also dead interval or hello time and dead time. But let me to say that one of the neighborship conditions in the OSPF is configuring the same hello interval and dead interval in both sides. You know that in EIGRP we don't have this requirement, but in the OSPF we have this requirement. Maybe you think why in EIGRP we don't have this requirement, but in OSPF we should configure the same hello interval and dead interval in both sides, because here we have different interpretation. Look at here. in the router 1, when router 1 connected to the router 2, it is possible that you configure in one side, for example, the hello interval and dead interval as a 10 and 40 second. The first is hello interval, the second is dead interval. After that, here on the router 2, you can configure the hello time or hello interval as 2 seconds, and after that the 6 seconds. When you are talking about the OSPF, actually the router 1 is sending the first hello in the time 0. Okay, this is the hello. We are sending this hello from the router 1 to router 2, and the next hello, okay, is sending on the 10 second. Because of that, here as you can see, after first hello we will have OSPF neighborship between the router 1 and router 2, but and you know that router 2 expect to receive the next hello before t equals 6 seconds, because here until the t equals 6 seconds we don't have the next hello, and we don't receive the next hello. Here the neighborship will go to the down state. Because of that, with this configuration in OSPF we will encounter with problem. Okay, you know that in OSPF we should configure both values with the same value because of preventing this type of problems. Okay, in OSPF, when you are configuring 6 seconds as the hello as the dead interval, this is the dead interval of the router 2's interface or the router 1 interface. Means we are using this 6 seconds for the R1, not for the R2. But if you are working with EIGRP, you know that this 6 seconds should be sent to the R1, and R1 should keep this time for the R2. Because of different interpretation between the OSPF and EIGRP, as you can see here, in OSPF we will encounter with problem. Because of that, in OSPF this is one of the requirement for neighborship, that you should configure same hello interval and same dead interval between two sides. If you configure different hello interval and dead interval, the neighborship will fail. Let me to show you. Look at here. First, in the router 1, now I'm going to first changing the hello interval interface serial 10. Look at here, IP OSPF hello interval. Assume that I'm going to configure the value from 10 seconds, the default value, to 5 seconds. Now do show IP OSPF interface serial 10 can show us that the dead interval is 20 seconds. I didn't configure 20 seconds because dead interval by default is using 4 times of the hello time. Here we have the 20 seconds. Maybe you ask me why the neighborship doesn't fail, because we are for example passing the dead time. Show IP OSPF neighbor in the router 2 can show us that now from dead time only 2 seconds is remaining, 1 second, and after that now we will for example lose the neighborship. As you can see, we don't have neighborship now. Because of that, it is necessary to configure in the same hello interval and dead interval in two sides. For example, here I'm going to configure IP OSPF dead interval 15 seconds. Show IP OSPF interface serial 10 now can show us that the hello interval is 5 seconds and dead interval is the 15 seconds, as because we have configured the dead interval. But in the router 2 now we are using different values. Show IP OSPF interface serial 10. Here we have hello 10 and dead 40. Let me to change them. Interface serial 10 IP OSPF hello interval for example 5 seconds. IP OSPF dead interval, okay, 15 seconds. It is so easy to understand that after some second we will have neighborship between the router 1 and also router 2. Also in the for example capture, we can see these values. Look at here, this is the hello from the router 1. Here you have this information on the OSPF hello packet. We have the hello interval and also hold time. Look at here, hello interval is 5 seconds and dead time or dead hold time is 15 seconds. In both sides now we are using the same values. Because of that, in the hello we have these values, and both routers can understand that they are using the same hello interval and dead interval or not. If this hello interval and dead interval, okay, are same, we will have neighborship. But if they have difference, okay, we lose the neighborship. Actually, we can say that we are using the OSPF hello, okay, for failure detection after the neighborship. And this is the secondary function of OSPF hello packet, and that is to ensuring that adjacent OSPF neighbors are still healthy and also available. You know that OSPF sends hello packet at set interval, okay, according to the hello timer. OSPF uses a second timer called the OSPF dead interval timer, which default to 4 times the hello timer. Upon receipt of the hello packet from a neighboring router, the OSPF dead timer resets to the initial value and then it starts to decrement again. Also, if you want to, for example, verify the hello time and dead time, or hello interval and dead interval, you can use show IP OSPF interface name, or show IP OSPF interface include, okay, it is easier, then timer, okay, after that pipeline. Here you can see we have that only the line in this show, okay, include the timer keyword, okay, and also here you can see the line of the one line only, the line of the for example, timer interval configured hello 5 dead 15 wait 15 and also retransmit 15. Okay, you will learn about these two other times. Wait is using in the DR/BDR election, and retransmit timer is using when we send one packet, okay, from R1 to R2, and but we didn't receive the link state acknowledgement. This is related to the link state. We should wait 5 seconds, and after 5 seconds we can retransmit the data or link state to the other side. Okay, the next criteria of the OSPF neighborship, or the next condition about the OSPF neighborship, is the authentication. You know that authentication is one of the optional parameters. This means that if you want, you can use authentication. If you don't want, you can don't use authentication, okay, or not use authentication. But if you enable authentication, the authentication should pass. Here, as you saw, I didn't configure any authentication. Because of that, as you saw, we didn't have any requirement for configuration, for example, of the key or some other things. Okay, but don't forget, if you configure the authentication should match in both sides. Let me to talk about the authentication and its details in the OSPF. In OSPF, we have 3 types of authentication. Let me to explain them because it is so important to understanding everything correctly. Look at here. In OSPF, we have 3 types of authentication. The first type is type 0. The second type is type 1. And the third type is type 2. Okay, what does it mean? The type 0 of authentication means no authentication. Okay, actually now we are using the type 0 authentication, and another name of no authentication is null authentication. Look at here, inside of the hello, you can see that we have authentication type of null. Null means type 0. Because of that, we don't have any password. Authentication data is for example empty. That's it. This is the no authentication with lower security. You know that an attacker can forge OSPF packets or gain physical access to the network. Okay, after manipulating the routing table, the attacker can send traffic downlink, okay, that allows for traffic interception, creating a denial of service attack, or perform some other malicious behavior. And we should enable OSPF for preventing neighborship from the neighbors from the, for example, from the with the OSPF router from one attacker. Because of that, it is highly recommended to enabling the authentication. Also, about the type 1 authentication, this is the authentication with the plain text or clear text. We can easily, okay, send one password to the other side, but you know that this is not so secure, because the attacker can intercept or can sniff this line, and after that it can find the password. Okay, I will show you. After that, the next method is the MD5 cryptographic hash. Let me to write here MD5 cryptographic, okay, hash. This is the most secure method that we can use it. You know that MD5 is the abbreviation of the message digest 5. Okay, when you are using the MD5, actually you are encrypting, you are hashing the password, okay, to the other side, and if the attacker can sniff the line with the hash, it cannot find the real password or the actual password. I will show you. The most secure method is the type 2, but if you want, you can use the type 1. You know that in type 0 we don't have any For example, we can say any security. Okay, how we can configure the authentication? We have two types of configuration of the authentication in the OSPF. Let me first talk about the interface specific authentication. Okay, it is so easy. About the type 0, we need to use this command for enabling the authentication. First, we should identify the authentication type on one interface. Router config interface name. Okay, and after that, on this interface, router config if, we should configure these two commands. IP OSPF authentication. This is the first command. What does it mean? It means that I am using the type 1 authentication. This is type 1. Type 0 doesn't have any configuration. Okay, IP OSPF authentication. After that, if you want to enable the for example key or configuring the key or password, you should use IP OSPF, then authentication key. Okay, and after that a password. This is the configuration of the type 1 authentication in router in OSPF. Also, for verifying the authentication, you can use show IP OSPF, again interface, show IP OSPF interface, then the interface name. Let me to show you. Between the R1 and R2, here in the R1 I'm using conft, then interface serial 10 IP. For example, OSPF authentication is the first command. After that, IP OSPF authentication. You know that when you are configuring the authentication, IP OSPF authentication, you are actually defining the method of authentication. Okay, then IP OSPF authentication key, for example, Cisco. Okay, as you can see now, we don't have neighborship because we enabled the authentication in one side, but in the other side we don't have authentication. Do show IP OSPF neighbor. As you can see, we don't have authentication. Okay, let me to show you also show IP OSPF interface serial 10. As you can see, show IP OSPF interface serial 10 can show us in the last line of this show. In the last line, you can see we are using simple password authentication enabled. Also in the capture, in the hellos received from the router 1, we have a authentication type 1 simple password, and the authentication data is Cisco. You know that I configured Cisco. And then in the router 2, let me to configure the authentication with the same method, IP OSPF authentication. That's it. Then IP OSPF authentication key. The key is Cisco. Now we will have neighborship, but you know that this is not a secure method. Okay, let me to wait some second. Now we have neighborship. Show IP OSPF neighbor. Now we have neighborship. Show IP OSPF interface serial 10. The simple password authentication enabled. Also in the router 2, again do show IP OSPF interface serial 10 can show us that we are using the simple password authentication. It is so easy. Okay, but you know that this is not a secure method because one attacker easily can find this password. Okay, how we can configure the next type, the type 2 of the authentication. Let me to show you. I am going to show you how we can configure the type 2. You know that in type 2, again, we should configure first the type of authentication, after that the key. Here we have the type 2 IP OSPF authentication, then you should configure message digest. Means I am using the message digest type of authentication or cryptographic hash. Then IP OSPF, okay, message digest key, okay, IP OSPF message digest key, and then for example key ID. After that MD5, then key string. Here actually we can configure multiple keys, and these multiple keys can be useful for when we want to change the keys. Let me to show you one simple example. First, we should remove the previous authentication, conf interface serial 10. Okay, no IP OSPF authentication key, and then no IP OSPF authentication in the router 1. Also in the router 2, no IP OSPF authentication key, and then no IP OSPF authentication. Now we don't have any authentication. let me to show you, do show IP OSPF interface serial 10 can show us that we don't have authentication. Also do show IP OSPF neighbor can show us that we have neighborship. Okay, all right, let me to configure the IP OSPF authentication now. Message digest means MD5, IP OSPF message digest key 1 MD5, for example Cisco. Okay, this is the configuration of the first site in the router 1 in the show IP OSPF interface serial 10. Now you can see that we are using message digest authentication, and also the youngest key ID means the key 1, because OSPF is using the youngest key means the latest configured key when you have multiple keys. And after that, in the router 1 now we don't have neighborship show IP OSPF neighbor, but if you verify the captures, 10121 now is sending is using authentication type cryptographic hash, then authentication cryptographic key ID is 1, and after that here you can see the authentication cryptographic data. Okay, let me to configure the router 2 also. Interface serial 10 IP OSPF authentication message digest, IP OSPF message digest key 1 MD5, and then the key Cisco. Don't forget that the key ID and also key string, both of them are using for creating the hash. Because of that, both of them should be same with the other side. Key ID and also key string. Now we have neighborship show IP OSPF neighbor. Also here show IP OSPF neighbor, we have neighborship, and in the capture file you can see that we don't send the password in clear text. This is the most secure method and most accepted method in the for example authentication of the routing protocols. But you know that in these two methods now we are using the interface based command. We have another type of authentication, we call it the area based authentication. Actually we can say that in area based authentication you can configure only the authentication type, not the authentication data. Let me to show you. Look at here. Assume that we want to configure the type 1 of the authentication in one area, in all interfaces in one area. You can use router config and then router OSPF, for example PID or process ID. Then here in the router config router, let me to show you, in the router config router we should configure area ID. Okay, then authentication. What does it mean? It means that we are using the type 1 authentication. Or if you want to configure the type 2 authentication, look at here. If you want to configure the type 2 authentication with area based command, you can use the commands as are similar with the interface based command. Router OSPF again process ID, and after that here on the router config router okay, a config then router, we should use the area ID authentication, and after that message digest. That's it. You know that when we are using the area type of authentication, actually we are configuring only the authentication type. For authentication key, again you should go to the interface and configure the interface. This is suitable when you have, for example, one router, okay, with multiple interface in one area. For example, R1 has a 3 interface, 4 interface, maybe more, okay, in one area 0. You don't want to configure an all interface IP OSPF authentication, IP OSPF authentication message digest. You can configure only one time the authentication type, but about the authentication key, you should go to each interface and configure the authentication keys. Let me to show you here in the router 1. I'm going to remove the previous configuration. Interface serial 10, no IP OSPF authentication or no IP OSPF message digest key. Okay, 1 MD5 Cisco 1, then no IP OSPF authentication message digest. Now we don't have configuration of authentication on the R1 interface. I can show you. Do show run interface serial 10. As you can see, we don't have configuration of the authentication on the serial 10. In the router OSPF 1, okay, in the router OSPF 1, you can configure area 0 authentication message digest. That's it. Area ID. Area ID authentication message digest. You know that until now I have configured only the authentication type. Now for authentication key, you should go again to the interface and then IP OSPF, for example, message digest key 1 MD5, then Cisco. This is the key. Okay, for authentication type, okay, we can use the area based command also, which show IP OSPF. You can verify the status of one area, as I mentioned before, area backbone quad 0. In this area, we are using a message digest authentication, or if you use area ID authentication, you are using simple password authentication on one area. But let me to emphasize that if you configure in one area, okay, in one interface, okay, the authentication type different than the authentication type that you have configured for one area, actually the authentication type on one interface has preference. Actually, the interface specific command has preference to the area based command. This means that assume that we have configured on the router 1 area 0 authentication message digest, means in area 0 interfaces we should use the message digest authentication or MD5 authentication. But on the interface you have configured on the serial 10 IP OSPF authentication, means on this interface I'm going to use the IP OSPF authentication, means clear text. The configuration of the interface has preference to the configuration of the for example area. Also in some cases, for example in the router 1 we have configured area, okay, 0 authentication, means I'm going to use for all interfaces in the area 0 the authentication type of the clear text, means type 1. But for one interface you don't use authentication at all. It is possible. You should go to that interface, okay, for the type 0 configuration of the authentication. You can configure this command, router config if IP authentication null. Look at here, this is so important to understand it correctly. Look at here, by default IP OSPF authentication null. By default on all interface we are using the authentication type of null. Because of that we don't need to configure IP OSPF authentication null on the serial 10. Only when you are configuring the area type authentication and you don't want to have authentication in one specific interface, you can configure IP OSPF authentication null for that interface. In most cases, it is recommended to configuring the authentication as the MD5, and it is recommended to configuring each interface independently from other interfaces with the authentication type and also the authentication keys. Actually, we know that for authentication we are using IP OSPF authentication or IP authentication type or IP OSPF authentication message digest. For the key in the clear text we are using IP OSPF authentication key password. In the type 2 we are using IP OSPF message digest key, not authentication key. Key ID MD5 and then key string. This is the story of the authentication in the OSPF, and as I mentioned before, the best practice is using the authentication type of the message digest. And finally we have another condition. Area type flag must be identical for that segment. You will learn about the area type flag and after that you can understand that what does it mean. But let me to say that for now in OSPF we have different area types. Okay, in OSPF we have different area types and you will learn about them in this class. About the area types, we have normal area, this is the default area type. We have stop area, we will learn about it. We have totally stop area, we have NSSA area, not so stop area, and also totally NSSA. You will learn about all of these areas in this class. Here we have a condition. When you are using in router 1, when you are configuring the router 1 interface in one stub area, other interface, router 2's interface is also should be residing in the stub area. This means that both routers should be residing in identical area. What does it mean? You will learn about it. But for now, let me to say that when we are configuring one side the area one area type, in other side we should use the same area type. Here In the router 1, let me to show you, if you check the show IP protocol, you can see number of areas is in this router is 1, means area 0. And this is the normal area. We don't have a stub area, we don't have an SSA area. You will learn about them. Also, in the router 2, look at here, show IP or protocol can show us again we have one normal area. Actually, these two interfaces are residing in the normal area. You will learn about these details in the future. Okay, let me to review the neighborship conditions in the OSPF. This is so important for us. The first condition is that both of the routers are using a router ID. This router ID should be unique between the router 1, router 2, and it is recommended to all networks. Inside of all networks, the router ID should be unique. The RID must be unique between the two devices. The interface must share a common subnet. As I mentioned before, you need to configure both interfaces with the same range of IP address. Then the interface maximum transmission unit or MTU must match. Yes, it's okay. The area ID must match for that segment, but we should configure the area ID with the same value in both sides. Then the need for a DR must match for that segment, means if in one interface you need to select a DR, in other interface again we should have the same requirement. You will learn about it more than this in the future in this class. OSPF hello and dead timer must match for that segment. I have explained it and you know it. The authentication type means the clear text, or means type 0, type 1, type 2, okay, should match. And also credential means authentication key, if any, must match for that segment. Area type flag must be identical for that segment. You will learn about the area type flag and the details of the area type. Because of that, now you know that we have talked about the OSPF neighborship or OSPF requirement, and after this video we can use these parameters for troubleshooting and for verifying the status of the OSPF neighborship in both sites.